everyone, and welcome to another episode of Tam Talks, the TED Talks with Tam. On today's episode, we're going to be doing a little bit of math. It's a little new, but we're going to be doing some math. And the section that we're going to be doing is section 2.3, the measure of central tendencies. Let's get started, shall we? A measure of central tendency is a value that represents a typical or central entry of data. The three measures of central tendency that we will be talking about today are mean, median, and mode. Let's use a real-life problem to help you better understand these measures of central tendency. I asked 11 dancers to do as many push-ups as they could. Here are the results. 8, 5, 8, 0, 1, 17, 4, 14, 30, 30, and 50. Do you want to see them do the push-ups? Because I know I do. Cue the video. Like now. Okay. That was tragic. Anyways, back to the lesson. The first central tendency that we will be talking about today is the mean. The mean is the sum of the data entries divided by the number of entries. To find the mean of a data set, you will use one of the following formulas. To find the sample mean, you must, number 1, order the data numerically. Number 2, follow the formula. The sum of the push-ups is 0 plus 1 plus 8 plus 5 plus 8 plus 4 plus 17 plus 30 plus 14 plus 30 plus 50, which equals 167. To find the mean, divide the sum of push-ups by the number of push-ups in the sample. When you divide 167 by 11, you get 15.182. So the mean number of push-ups is about 15. Next central tendency is the median. The median is the value that lies in the middle of the data when the data is numerically ordered. It measures the center of an ordered data set by dividing it into two equal parts. To find the median, you must first order the data numerically, which we have done in the following. Because there are 11 entries, the median is the middle or the sixth data entry. So, the median is 8. The final measure of central tendency that we'll be talking about today is the mode. The mode is the value in the data set that occurs the most often. If there is no number that is repeated in the list, then there is no mode for that data set. If two entries occur with the same greatest frequency, each entry set is a mode, and the data set is called bimodal. To find the mode, you must first order the data numerically. After you order the data, you can see that the number 8 occurs twice, so the mode is 8. But wait, we're not done yet. Although the mean, the median, and the mode each describe a typical entry of a data set, there are advantages and disadvantages of using each. The mean is a reliable measure because it takes into account every entry of a data set. However, the mean can be greatly affected when the data set contains outliers. An outlier is a data entry that is far removed from the other entries in the data set. There's also a weighted mean. The weighted mean is the mean of a data set whose entries have varying weights. You can find the weighted mean by the following formula. If data are presented in a frequency distribution, you can find the mean of a frequency distribution of a sample by x bar equals sigma times x times f divided by n, where x and f are the midpoints in frequency of a class respectively. If this frequency distribution represents a population, the mean of the frequency distribution is found by mu equals sigma times x times f divided by n. As you may know, a graph can reveal several characteristics of a distribution. One of those characteristics is the shape of the distribution. There are three main shapes of distribution. A frequency distribution is right-skewed or positive when fewer data plots are found to the right of the graph and the tail of the graph is going towards the right of the mean, such as this one. A frequency distribution is symmetric when you can draw a vertical line down the center and the two sides mirror each other, like this one. A frequency distribution is left-skewed or negative when fewer data plots are found to the left of the graph and the tail of the graph is going towards the left of the mean, like this one. Well, that's all for today, folks. I hope you learned something, and if you didn't, I'm sorry. Anyways, stay tuned for next time when we learn how to screw on a light bulb. Have a good day. This was Tam Talks.